Hi there, welcome back to Math 1120 Calculus. Today we're going to look at section 2.2 on our notes, which is about limits. So hopefully you have those with you, and we're going to go through some of the definitions and overview of the section, and then we're going to work on some problems. So we're still working on limits like we did in the last section, and it says at the top, in the previous lesson we learned about one-sided limits. Now, in this lesson, we will develop the concept of a limit in general by considering the left and the right-hand limits simultaneously. Okay? So remember last time we looked at left and right-hand limits, and we did look at the definition that said the limit at any value only exists if the limit from the left and the limit from the right were the same. We did that at the end of the last lesson. So here we're going to go through a couple more definitions and including that one, but a little bit more into limits in general. All right, so the objective for today is basically just to determine the limit of a function if the limit exists as x approaches a real number a. Okay, so again, just working straightforward with limits. All right, so some of the concepts and definitions we're going to be working on today. Number one says, we say that the general limit of a function f as x approaches a real number a exists if and only if the limit as x approaches a of f of x equals L, where L is a real number, okay, real number. All right, and remember we did this last time that when you are given this type of a problem and you don't have from the left or from the right, the little plus or minus sign up there, remember that means you have to check both and make sure that both sides give you the same. All right, number two says, if the limit as x approaches a of f of x equals positive or negative infinity, then the general limit of as x approaches a of f of x does not exist. We did a couple of those last time as well. And in number three, if the limit as x approaches a from the left of f of x does not equal the limit as x approaches a from the right of f of x, the limit does not equal, the left limit does not equal the right limit, so then the limit as x approaches a of f of x does not exist. So that kind of goes in line with number one, okay? So we're going to talk about just plugging in the limit value here in a minute, which we did a little bit last time, but you'll see how these two kind of work together, okay? All right, in number two, we wrote infinity and negative infinity in the last section. Typically, if it goes to infinity or negative infinity, you can write that, but remember that if a limit does go to infinity or negative infinity, then the limit does not exist, okay? We usually write infinity or negative infinity just so we, if we were looking at trying to graph the function, we would know which way it goes. But this is the answer. The limit does not exist if you can't give a real number value, okay? So that's kind of why that's there. It's not really a real number because it goes on forever, so we can't give an actual value. All right, let's look at number four. Number four says, when taking the limit as x approaches a number a, that sounds kind of weird, but when taking the limit as x approaches a value, okay, whatever that number is that we're looking at, so in this case a, always plug in that value that x approaches to see what format results. One of three things will happen when you plug a in for x, okay? Each of these next three situations require a different approach. So again, we touched on this last time. So the first thing that will happen, if you plug in the limit value that you're looking for, you will get an actual y value result, okay? If you get a result, then that is the limit, and then you don't need to do anything else. So those obviously are the easy ones, but you're going to always plug in the value, okay? That's always going to be the first thing you do when you're looking for a limit is plug in the number value and see what happens, because all three of these things require you to do that. So the nice one is if you get a number answer, that is the limit and you don't have to go any farther, okay? All right, there's two other cases. So the two other cases, you would plug in the value and you would get b over 0. Okay, that would be what you would end up with when you plug in the value. So b stands for some non-zero number. So b is not going to be 0, and the bottom, the denominator, will be 0. So it says when this occurs, then the limit will equal either infinity or negative infinity, and therefore the limit does not exist. So this is kind of nice because if you get a number divided by 0, then you automatically know your answer is either going to positive or negative infinity, and you know that means the limit does not exist. Okay? So it goes on a little further to explain this a little more that says that is, if the numerator has a limit different from 0, and if the limit of the denominator is 0, then the limit of the quotient must fail to exist. Okay, it says to evaluate this type of limit, create a table of values like we did in the last section. So remember in the last section, we could see when we did our table, if the numbers kept getting bigger and bigger towards positive infinity, then we knew it went to positive infinity. If the numbers got smaller and smaller, then that was going to negative infinity. Okay, so it's nice to be able to plug in the number automatically and kind of know what to expect. So remember number 1, we're going to plug in the number and get a value, and that's our answer. Number 2, we're going to plug in the value and come up with a number over 0. That means our answer does not exist. We just need to know, is it going to positive or negative infinity? And then the third type is what happens when the format you get with your result is 0 over 0. So when you plug in the number, you're going to get 0 on the top and 0 on the bottom. It says when this occurs, the limit may have a numerical y value result, and it then would exist. Okay, so when you get 0 over 0, that means you're actually going to get a number value. It says this type of expression is called indeterminate form, and it says that is a limit expression of this type. The limit is x goes to a of g of x over f of x. So when you have a division problem or a rational function, where the limit as x approaches a of the numerator equals 0, and the limit as x approaches a of the denominator equals 0. This is called indeterminate form. Okay? So when you see this, that means you got to keep going and figure out what the actual answer is. So number 5 talks about how to do that. It says indeterminate forms are special cases whose limit can often be evaluated by using algebraic simplification. One of those strategies of solving a problem that is an indeterminate form, the type 0 over 0, is given by a two-step method. And that is 1, replace the quotient with a simplified expression after factoring, and then evaluate the new limit problem by substituting in that a value again for x and simplifying your answer and getting a number. Okay? So 0 over 0 means we have some work to do. And I touched on that back in the last section. We did one factoring problem. I don't remember what number it was, but remember I told you we could do it by graphing or by the table, but I did it by factoring. It was grouping. So I kind of started us on that process in that last section. So today we're going to work on those even more. All right, and lastly, number 6. These 3 result types and subsequent solution techniques are also applied to left and right-hand limits. So anything that we can do with a regular limit, we can do when it's a limit that approaches the left or the right side. Okay? So same techniques no matter which way we're doing that. All right, so let's look at some problems. We're going to start with the graphs again. Kind of look at that. This is good practice for that. Paying attention to the notation and what kind of limit we're looking for. Okay, so 1a says find the limit as x approaches -2 from the left-hand side. So again, remember, when you're asked to find the limit as x approaches some value, it wants to know what is y approaching, okay? Your limit is what value is the y value approaching in this problem. So if we go to the graph and go to -2, which is right here, and we want to come to -2 from the left-hand side, which is over here, when this graph gets close to -2, what is the y value approaching? The y value is up here, so it would be approaching 1. Okay, that's the y value from the left. Find the limit as x approaches -2 from the right-hand side. Okay, so now I'm going to -2, but from this side of the graph, the right-hand side. So here's the graph. So as I come towards -2 from the right, what y value am I approaching? Still approaching 1. Okay. Part C says, now find the limit as x approaches -2 of f of x. So remember, when there's no plus or minus here, okay, the limit from the left and the limit from the right must be the same. If they are the same, that is the limit. If these are different, then the limit of this would not exist. So both sides have to meet up at the same point. Okay? All right, let's look at D. Find the limit as x approaches 3 from the left. All right, well, here's 3. So on the left would be this side. So find the graph that's on the left side of 3, which is right here. So as I approach 3 from the right, what is the y value approaching? The y value is approaching 5. Doesn't matter that it's not there. It's what is it getting close to? So it's getting close to 5. Okay? Find the limit as x approaches 3 from the right. So again, here's 3. Go to the right of that, find the graph, and approach 3 from the right-hand side. It's going down towards negative infinity, right? So this one is going down to negative infinity, which remember, does not exist. That's the answer we want, okay? So F wants to know what's the limit as x approaches 3. Well, the limit as x approaches 3 does not exist because these are not the same. The left side, the right side must be equal. So this does not exist, okay? All right, now number 2 is our basic rule for limits. When you're given an expression, okay, and you're asked to find the limit, always plug that number in and see if you get a value. If you get a value, that is the answer. That is the limit. So for number 2, the limit as x approaches 1 of this polynomial, 3x cubed minus x squared minus 2x plus 4, first thing I'm going to do is plug in 1. So 3 times 1 cubed minus 1 squared minus 2 times 1 plus 4. I'm going to work that out and see what I get. Okay? All right, so do your powers first. So 1 cubed is 1. Okay, 1 squared is 1. 2 times 1 is 2. And then you have that plus 4. And then also here we have 3 times 1, which is 3. So let me write that down and then we'll work that out. All right, so 3 minus 1 is 2. 2 minus 2 is 0. 0 plus 4 is 4. So we got a numerical real number value. So that is the limit. Okay, so if you plug it in and you get an answer, that's your limit. All right, now, number 3, another limit problem. Okay, so what is the limit as x approaches -5 of x plus 5 over -4x squared plus 100? Well, the first rule of thumb is to plug it in and see what you get. So I'm going to plug in -5 in the top, and in the bottom I'm going to do -4 times -5 squared plus 100. I'm doing this off to the side because I know I'm not going to get an answer here, so I want to leave room to do the rest of the work. All right, and you can plug these in your head just to see what form you're getting, but I want to show you as this is how we're starting this. So you always want to plug it in, whether you do it in your head or do it on paper. I need to know what I'm going to get when I plug this number in. All right, so in the top I get 0, and in the bottom, -5 squared is positive 25. 25 times -4 is -100 plus 100, so I get 0 over 0. All right, so remember what that tells me. That's indeterminate form, which means I'm going to get a numerical answer. When I work this out, I'm going to get a number answer. So remember the 2 steps. We want to factor, simplify, and then put in the -5 again. So that's why I've left room over here for this. So when you simplify, you want to keep the limit in the problem until you start evaluating. So don't get lazy and just start factoring. You need to write the limit on each step until you're ready to plug in the number again. When I plug in numbers, then I don't need the limit. But if I'm just working a problem and simplifying it, I need that. That's part of the problem. Okay? All right, so the top is going to stay x plus 5. I can't do anything with that. But in the bottom, I can factor out a negative 4. They both have a 4 in common. And remember, I always said try to keep your first term positive, so I want to factor out a negative 4. So if I factor out a negative 4, divide both of these terms by negative 4, so negative 4x squared divided by negative 4 will leave you positive x squared, and 100 divided by negative 4 will leave you minus 25. All right, still can't do anything, so I got to keep going. So if I'm going to keep going, I'm going to write the limit as x approaches negative 5 again. In the numerator is still x plus 5. In the bottom, I factored out that negative 4. And now you're left with x squared minus 25, which is a difference of squares. So you can keep factoring this. If you remember difference of squares, you take the square root of both terms, and then one gets a plus sign, one gets the minus sign. So the square root of x squared is x, and the square root of 25 is 5. So that means that factors x plus 5, x minus 5. And remember, you can only do the difference of squares if that's a minus sign. Okay, that's how that factors. All right, so now notice you can cancel the x plus 5's. Those are the same in the numerator and the denominator. Still simplifying, so I still need the limit. And in the top, since everything's gone, I have 1. And in the bottom now, I just have negative 4 times x minus 5. Okay, so I've taken this problem and simplified it down to this problem. But I'm still haven't taken the limit yet, right? I took it here and found out 0 over 0, which means I got to keep working on this. So I reduced it down by factoring. Now I'm going to plug in negative 5 again. So now that I'm plugging in negative 5, I don't need the limit anymore. I'm just evaluating now. So I'm going to do 1 over negative 4, and then x approaches negative 5 for x minus 5. Okay? So 1 over negative 4 times negative 5 minus 5 is negative 10. And negative 4 times negative 10 is a positive 40. So you get 1 over 40, which is a real number. So that is the limit. Okay, so let me say that one more time, how this went. So this was that indeterminate form. So we noticed we got 0 over 0 when I plugged in negative 5 into the original problem. That form tells you you will get a numerical answer. And one of the ways to get the numerical answer is to simplify the problem by factoring, simplifying that down to a new problem, and then plugging in that limit value again. Okay, the x value for your limit. So we'll do a couple more of these obviously as we go through, but that's what we did and that's how we got our answer. Okay. All right, let's go to number 4. Okay, so again, remember, we're going to always plug in. Do it in your head, but I'm going to write it out because if you do it in your head and you come back to this later, you're going to forget that you did it in your head. So we're going to first plug in 2 and see if we get an answer. Because remember, if you put 2 in here and you get an answer, you're done. Okay? So I'm going to do that over to the side. So I'm going to check and see what I get when I plug 2 in here. So 2 squared minus 4 in the top, and in the bottom, 2 squared plus 4 times 2 minus 12. Okay, what do you get when you do that? So in the top, 2 squared is 4, 4 minus 4 is 0. And in the bottom, 2 squared is 4 plus 4 times 2 is 8. So 4 plus 8 is 12. 12 minus 12 is 0. So we get that indeterminate form again, which means I can factor this and simplify it. Okay? All right. So if that's what I'm going to do, we're going to do the limit as x approaches 2. And then let's try to factor this. So in the numerator, you have a difference of squares, just like the one we finished. So I can take the square root of this number, the square root of this number, and one gets a plus and one gets a minus. Okay, so that would be x plus 2, x minus 2 in the top. Remember, you guys have to be able to factor, and if you can't factor well, you need to go back and look at that section in Hawks or get help from me or the MLC, but make sure you can factor. All right, in the bottom, you have the trinomial. So we did one of these last time, but factoring trinomials, we need factors of 12 at the back, but they have to give us 4 in the middle when we FOIL it out. So remember, I told you to read this backwards. I need factors of 12 that subtract to give you 4. Well, think about the factors of 12. 1 times 12, 2 times 6, 3 times 4. Only one of those pairs will subtract to give you this number, and that would be 6 minus 2. So that's how you know what to use. So I'm going to use 2 and 6. And then all you have to do is figure out the signs. How do I get a positive 4 when you have a 2 and a 6? So to get a positive 4, the 6 would have to be positive. The 2 would have to be negative, because if you add those together, you get positive 4. But if you multiply those together, you get this number. So that's what you want. You want to be able to multiply those last two numbers to get this, and you want to be able to add these numbers together to get that. All right, so now that we factored, do we have anything in common? Yes, we do. You have the x minus 2's that will cancel. So now we're going to simplify this. The limit as x approaches 2 of x plus 2 over x plus 6. So we simplified this down to this by factoring. And now we're going to plug in the 2 again and see what we get. Okay. So now I don't need the limit anymore, because remember, when you plug in, that's the time you don't need to write limit. So x approaches 2, so 2 plus 2 in the top and 2 plus 6 in the bottom. So that gives me 4 over 8, which is 1/2. So that is my limit value as x approaches 2. Okay? All right, number 5. Oh, I'm sorry if I slid that up too much. Some of you guys might still be writing. You can always pause on a video, which is nice. All right, so the answer for number 4 was 1/2. All right, so let's move on to number 5. Again, we're going to just plug in. The limit as x approaches 1 from the left. Now remember, just because it's coming in from the left, remember in number 6 that we can do the same rules for left and right. So I can still plug in 1 into this problem to see what kind of problem I'm going to have. So when I plug 1 in here, I get 1 squared plus 1 minus 12 over 1 plus 1. Okay? All right. So 1 squared plus 1 minus 12, and then as x approaches 1, so 1 plus 1. All right, so that gives me 1 squared, which is 1, plus 1 minus 12 over 2 in the bottom. Well, 1 plus 1 is 2. 2 minus 12 is negative 10 over 2. So I get negative 5, so there's my answer. Remember, if you plug it in and you get an answer, you are done. Okay? All right, so that one was just straightforward. I plugged it in. So sometimes you plug it in and you get an answer. Those are the nice ones. Sometimes you plug it in and you get this, which means you got to keep working. And we haven't done any yet where we get a number over 0, but I'm sure those are on here, so we'll keep moving. All right, so number 6, start by plugging in 7. So if I plug in 7, I get 7 minus 7 over 7 squared minus 49. This time, 7 minus 7 is 0. 7 squared is 49. 49 minus 49 is 0. So this one is indeterminate, which means I must factor and see what happens. All right, so the limit as x approaches 7 from the left. X minus 7 at the top, I can't do anything with that. But the bottom is the difference of squares. Square root of the first, square root of the second. One gets a plus, one gets a minus. So the square root of 49 is 7. So x plus 7, x minus 7. All right, so now I can see I'm going to cancel the x minus 7's. So that leaves me with the problem. The limit as x approaches 7 from the left of 1 over x plus 7. A lot of you guys, when you cancel everything in the top, you think there's 0 there and you get rid of your fraction. Please don't do that. When you cancel everything, you're left with a 1, okay, not a 0. So there's 1 still up there. All right, so now we're going to plug in the 7 again, see what we get. So now when I plug in 7, 1 over 7 plus 7, I end up with 1 over 14, which is a numerical answer, so that is the limit. Okay? All right. Well, let's try number 7. The limit as x approaches 4 from the right for x plus 5 over x minus 4. So plug in 4. So 4 plus 5 over 4 minus 4. So this time we finally get something different. We get 9 over 0. All right, so remember what that means. It means this is either going to positive or negative infinity, which means the limit does not exist. Okay, so I know the limit does not exist on this one, but I want to know for graphing purposes, which way does it go? So this is good practice anyway for our calculators. So I'm going to plug this in my calculator under y equals. So parentheses x plus 5, close your parentheses, divided by x minus 4 in parentheses. Close your parentheses, make sure you put parentheses, and then hit enter. Okay, go to your table. Remember, if you have any values here left over from last time, hit delete, delete, delete until you get rid of them all. All right, and we're approaching 4 from the right. So think about your numbers you want. So here's 4, here's 5, because we're going from the right. So we can use 5, then we can use 4.5, then we can do 4.1, right? 4.01, and so forth. We want to get closer and closer to 4 from the right-hand side. All right, so I'm going to do 5, 4.5, 4.1, 4.01, 4.001. Okay, so prove it to yourself that you are going to either positive or negative infinity. So we did on this graph, we did 5, 4.5, 4.1, 4.01, right? And you know, just enough for you to believe that. So we did 10, 19, 91, 901, 9001. So you see that we're going towards positive infinity. Numbers keep getting bigger and bigger. Okay. So this is going to positive infinity. All right. So I see that. That's a more descriptive answer. But remember, when your function goes to positive or negative infinity, the limit does not exist. Okay? All right, number 8. Plug in 2. So find the limit as x approaches 2 from the right of x plus 2 over x minus 4. Well, if I plug in 2 in the top and 2 in the bottom, I am going to get an answer of 7 over negative 2. So negative 7/2 is the answer. You could write negative 3.5. That's fine too. Okay. So negative 3.5. Plug it in. If you get a number answer, you're done. All right, number 9. Find the limit as x approaches 3 of 3 minus 13x plus 4x squared over x minus 3. All right, first off, I want to rewrite that because if I have to factor, I need the squared term to be first, so it makes more sense to me. So I'm going to write it this way. Okay, I don't have to do that now, but I like having things in descending order, so I put the positive 4x first, the minus 13x, and then that's a positive 3, right? Okay, so we're going to plug in 3. So 4 times 3 squared minus 13 times 3 plus 3 in the top, and in the bottom 3 minus 3. All right, so I see that I'm getting 0 in the bottom, right? So I just need to know what's happening in the top. All right, so I've got 3 squared, which is 9. 9 times 4 is 36, minus 13 times 3 is 39, plus 3. So 36 minus 39 is negative 3, plus 3. So I am getting indeterminate form, which means I can factor this. Okay, I'm going to be able to factor this and simplify it. All right, so let's factor. So keep your limit with the problem. Okay. These are the harder ones to factor, so we have to figure out how that numerator factors. Bottom's easy because it's already done. All right, so I need to know what times what gives me 4x squared. So remember, I got a couple possibilities. I could do 4 times 1, or I could do 2 times 2. And then luckily for 3, there's only one way to get 3. 3 times 1. The problem is I need to make sure when I FOIL, I get, remember, the 13 in the middle. Okay, so you guys have learned this lots of different ways. I'm just going to do it by trial and error. So I'm going to do it up here. So I know I can either do 2 times 2 or 4 times 1. So I'm just going to try. And then I know I can either do 1 times 3, right, or 3 times 1. So I'm just going to try it this way, see if anything happens. So if I do the top, when I do the outer, I get 6, and the inner is 2. So that's not going to give me 13. Okay, so then maybe I'll do 3 here and the 1 there. It's another possibility. So now the outside, the inside is 6 and the outside is 2. That's still not 13. So I don't think I can use 2 times 2. All right. If I do 4 times 1 to give me 4 and 3 times 1 to give me 3, outside is 4, inside is 3. That doesn't add up to be 13. So last option is going to have to be if I move the 1 and the 3 around. Now I get 12 on the outer, 1 on the inner, and 12 and 1 is that. Okay, so I know there's lots of tricks to the trade on how to factor those kind of trinomials. This one I knew wasn't bad because there was only 2 options for this and 1 option for that. So that's just, you can always trial and error and just FOIL it out. All right, so now I know I can use 4x and x, and then 1 and 3. Now I just got to figure out my signs. But I need a negative 13, so the 12 had to be negative, and the 1 has to be negative, because that gives me a negative 12 and a negative 1, which is that negative 13. Okay, so we factored, and look, I have a common factor, which will cancel. So now I'm left with the limit as x approaches 3 of just 4x minus 1. Now, when you have 1 in the bottom, obviously you don't need to put the 1 down there, right? But when there's a 1 left in the top, like we had on this problem, just don't, so because some of you write that as just x over 7 because you think that's gone. But if the what's left is in the bottom, it's got to stay in the bottom, which means there's a 1 in the top. This one, everything canceled in the bottom, so that's fine because this is left in the top, okay? All right, so plug 3 into this new limit problem. So 4 times 3 minus 1. So we get 12 minus 1. So the limit is 11. Okay? All right. So now you've seen all 3 forms, the 0 over 0, the number over 0, like this one, or just plugging it in and getting an answer. So those are the things that are going to happen to you. So those are the 3 things you're looking for. All right, now for the last 2 questions at the top, it says, we now desire to use limits to evaluate the difference quotient as we let h approach 0, where h represents the distance between 2 points that we are letting shrink to 0. And then it says in a few sections, we will define this particular limit as the derivative. That's the name it's going to give itself. But I just want you to understand what this means. What about h, okay? What does this mean? We're going to use h represents the distance between 2 points that are shrinking to 0. So remember when we do the limit, we're trying to get as close as we could to whatever this value is. And in number 7, we went from the right. So you see how we went from 5 and then we ended up at 4.001. So the distance between these 2 points was shrinking, right? So the distance between 5 and 4, when I used 5, that distance was 1 whole unit. When I used 4.5, the distance shrunk to 1/2. When I used 4.1, the distance here was just 0.1. So when I did this number, the distance between 4 and here is just 0.01. And so the distance for the last one was 0.001. So the distance is getting so small, it's almost at zero, right? There's almost no space between the two values. So that's what this is saying, okay? Without actually having to write all those numbers down, when we say h is approaching zero, h actually represents two numbers, but the difference between those two numbers are so small, it's approaching zero. Okay, I hope that makes sense. So in the derivative formula, in this difference quotient formula that we're getting ready to do, that's why we just have h in the bottom. Okay, because this distance between those numbers, the limit, is getting so small, we're just going to call it zero. Okay. All right, so hopefully that makes sense, but if not, you can still evaluate. We learned about function values. So for number 10, you are asked to find the limit as h approaches 0, okay, of f of 3 plus h. So remember what this means. It means take your function, and everywhere there's an x, you're going to replace it with whatever's here. So we're going to replace this x with 3 plus h. So that's 3 plus h squared minus 2. And I'm going to put that in brackets just so you can kind of see that's this first part. Okay? Then it says minus, and I'm going to put this in parentheses. So minus f of 3. What does that mean? Well, that means plug 3 in here everywhere there's an x. So over here, I'm going to write 3 squared minus 2. Okay? So here's your function. And in the first part, it said to replace this x with 3 plus h. That's right here. Right? That whole function with just 3 plus h in there. And then this one said replace the x over here with 3. But you got to subtract it. Okay, so that's that minus sign. And then the whole thing has to be divided by h. So that's the work we got to do right now. All right, so next step is to take the limit as h goes to 0, and we're going to simplify this. 3 plus h squared. We did this a bunch of times last time, but 3 plus h squared means this, right? So if you're asked to square a polynomial, you got to FOIL it out. So 3 times 3 is 9. Outer is 3 times h, which is 3h. The inside is 3 times h. And the outer, h times h, is h squared. So when you simplify that, you can add those together. So we get 9 plus 6h plus h squared. Okay, 9 plus 6h plus h squared. And then don't forget that minus 2. So that's that. Okay. So here's this that we just got. 6h came from here. 3 plus 3 is 6h. Then we had the minus 2. And now minus 3 squared minus 2. So I'm just going to keep 3 squared is 9 minus 2. We'll do the simplifying on the next part. And all of it's still over h. All right, so now we're going to take the limit as h goes to 0. Let's simplify this. So 9 minus 2, I can add those together or subtract. 9 minus 2 is 7 plus 6h plus h squared minus, and then 9 minus 2 is 7. And all of that is over h. Okay. So that equals the limit as h goes to 0. So 7 minus 7 goes away. That's 0. So now you're left with just 6h plus h squared over h. All right. So remember we did this last time. If you can factor out 1h from each of these terms, then we can cancel it with that h. So that's what I want to do. I want to factor out 1h from each term in the top. Okay, so take 1h out of 6h, that leaves you 6. And take 1h out of here, that leaves you h. Still divided by h. Now you can cancel the h's. So we are now left with the limit as h approaches 0 of 6 plus h. So we took this problem, well actually this problem, right? We plugged it in and we worked it all the way out till we got rid of that h in the bottom, because as long as that h is in the bottom, I can't get an answer, right? I can't divide by 0. So I can't plug 0 in here until I get rid of that. So now I have a term where I can plug in 0. So now we're going to evaluate. So 6 plus 0, because h is approaching 0, is 6. So there's your limit. That would be the derivative or the difference quotient, but we'll talk about that. Okay. But, you know, and why didn't I plug this in right away? Well, number one, I don't plug it in because I got variables in here. But I know I can't plug this in because I see that I'm going to be dividing by 0. So I can't do that anyway. So when you get a difference quotient problem, you always have to simplify and evaluate it first before you evaluate it. Okay? All right, so let's try it one more time on number 11. So we're close to the same problem. Okay, we've got the same function, x squared minus 2, but this time notice your difference quotient is different. Here we used a number in h, and here we're going to keep x in the problem in h. Okay, so our answer is going to have x's in it, not a number answer, which is fine. I won't get a number answer if there's no numbers in here. Here I had a number, so that's why I got a number. All right, so same thing, except we're going to substitute in x plus h here. All right, so the limit as h goes to 0. So we're going to replace this x with what's in here. So that would be x plus h squared minus 2. I'm going to put that in brackets because that's the first part. Then the minus sign. And now parentheses for f of x. Well, f of x is just this, right? That is f of x. So x squared minus 2. So no numbers this time, just we're keeping x's in here. So it looks a little bit worse because we have more variables. Still going to do the same thing. All right, so we got to FOIL this out. Okay, x plus h squared. FOIL that out. That means x plus h times x plus h. That is not just x squared, h squared. Okay, a lot of you guys will do that. That is not how you multiply that out. You'll get the problem wrong. So please know when you see square, it means FOIL. You got to multiply it by itself. All right, so first is x squared, outer x times h, inner h times x, which is x times h, and last h squared. We did this last time. So you end up with x squared plus 2xh plus h squared. You really need to remember this because you're going to do it quite a bit here at the beginning of the semester. All right, so x plus h squared is this. So I'm going to write the limit as h approaches 0. So instead of x plus h squared, I'm going to write this. X squared plus 2xh plus h squared. And then you have the minus 2. And now I know I changed from brackets to parentheses. You could keep it brackets if that makes more sense to you. Okay? I don't want to confuse you, so. But I only use brackets here because I had parentheses. But here I don't have anything. But if you can keep those brackets, that's perfectly okay. All right. And I'm going to go ahead and leave the top the way it is. I'm not going to do anything to that yet. So all I wanted to do in that first part was FOIL out this, okay? Because now I have all individual terms. Okay, so next step. All I'm going to do here is see if I can add anything in here, which I can't. There's nothing in here that is the same. So I'm just going to write all that down. X squared plus 2xh plus h squared minus 2. Now, we're subtracting the function, right? Subtract the function. So remember what we did last time. When you subtract the whole function, all your signs in here have to change. That's why it's real important you put this in parentheses. So if you don't, you're going to make this minus, but you're going to leave that minus. And that would not be correct. So when this is minus the function, that means change all the signs. So it's going to become minus x squared and a positive 2. Remember, there's an invisible 1 there. So negative 1 times x squared is negative x squared. Negative 1 times negative 2 is positive 2. All right, and all that's still over h. We're almost done. A lot of steps on these, but they're all very similar. So you just kind of have to practice. And then you'll see, once you get the hang of it, you're doing the same thing pretty much all the time. All right, so now we're going to look for like terms. So you have x squared minus x squared, that's 0. You don't have another xh, you don't have any h squares, but you have a negative 2 and a positive 2. That is also 0. So now you're only left with 2xh plus h squared over h. Okay, I still can't plug 0 in because I see I'm still got 0 in the bottom. So remember this last step, just like above in number 10, if you can take one h out of each term in the top, factor it out. So the limit as h approaches 0, I'm going to take an h out of the top for each term. So if you take one h out of here, that leaves you with 2x. And if you take one h out of here, you're left with just 1h. And it's still over h, but now you can cancel that h with that one. So now you're left with just the limit as h approaches 0 of 2x plus h. Now you can plug in 0, because now you'll get an answer. So the limit as h approaches 0 of 2x plus h. So now we can let h go to 0. So 2x plus 0 equals 2x. So there's your limit. Has a variable in it because our problem didn't have any numbers in it. So if your problem just has x's in it, then your answer is going to have x's in it. So you see, it was very similar to number 10, but a lot of different little steps in there when there were no numbers involved. Okay? So you're going to get some similar to this, so just follow this as your guide. Use the numbers that you have, and hopefully you'll be able to get through it. But the steps are always the same, you just will have different number values. Okay? All right, so that does it for section 2.2. So work on your homework. Let me know if you have any questions, and I'll see you back here next time.